Good day, everyone, and welcome to Chicken Michael's Knowledge Series. Welcome again. Now, let's talk about process improvement techniques. Has the second element of the manufacturing process reliability pillar, process improvement techniques. Now, process improvement relates to maintenance and reliability or relates maintenance and reliability activities to manufacturing or production processes. The whole idea is a process has a way it functions, and over time, we may be able to uncover gaps or opportunities for improvement in the processes, and especially if we're deliberate in trying to identify and uncover opportunities for improvement, alongside having uh, a deliberate plan, right, or deliberate tools or a deliberate system engineered towards process improvement, that we are likely to see we're likely to see improvements implemented and see the payouts. Now, the goal is to focus first on continuous improvements, right? Identifying production losses and applying best practices to cost, risk, and benefit analysis. It's important to say that sometimes these losses can come obvious. So, in other words, if we look at a system like if we probably do an OEE and we get a number like 75 against a target number like 85, like in the video we watched initially, well, clearly there are some production losses that are obvious, right? But sometimes your production system might appear to even be functioning at its best. In fact, even the best amongst his peers, but you still discover that there are opportunities to improve, right? So yes, what you want to do is to know how to look for opportunities to improve, whether they are tied to explicit production losses or there's just a way to improve that might not have manifested yet as a loss, but will still be evidence of efficiency when applied. The goal is to apply best practices for cost, risk, and benefit analysis. Right. Now, process improvement techniques should involve everyone within the organization. So anyone who operates, owns, or maintains a process should be brought in because it's supposed to be team effort. We also want to ensure that we have a culture of a culture of continuous improvement, a culture of empowerment where people take responsibility for the outcomes of the processes they own. Culture of discipline and accountability is very good for having a continuous improvement trend or having a for building a continuous improvement culture. Process improvement techniques should, of course, take us closer to our business goals and help us all to work together in a better way and achieve greater level of employee and customer satisfaction. So we have a couple of tools like ISO standards, ISO 9001, total productive maintenance for comprehensive process improvement. Now let's look at the concepts. The first concept of process improvement is zero defects. Now, the whole idea of one of the first things that comes to everyone's attention, to our attention when we talk about process improvement is its relationship with quality management, especially the work of Joseph Juran that emphasized zero defects. So, according to this zero defect school of thought as our first concept, that we should strive for zero defect in our processes, in our production, and in our maintenance, right? So, what are the things we need to do? What are the things we need to invest in? What are the processes we need to improve to be able to ensure that we reduce our defects, the errors in our process gradually until zero, right? So of course you would see things like resource allocation, training and development of the workforce, ensuring that we have a supportive working environment. Supportive working environment can do a lot for us. For instance, having data available, having electronic tools, having using early detection mechanisms. These are all things that can support achieving a zero defect objective. And let's look at the tools we have. Well, of course, we have total quality management. Now, total quality management is a corporate effort to achieve or to improve quality through customer satisfaction, employee involvement, and continuous progress monitoring using customer feedback and critical success factors. So let's look at it this way. Now, total quality management, first of all, is customer focus, right? Yeah, so the whole idea of quality management is attempting to build a product or process a system that is fit for customer use and consumption. These products or these outputs or even the process are supposed to satisfy or give customers the maximum level of satisfaction that we can profitably afford. Now, the so yes, total quality management has a customer service focus, and then again there's also the focus on statistical process control. Remember when we spoke about that SBC where we use data to so total quality management is evidence-based. We use statistical process control. We use data collection, data analysis, data interpretation, to be able to make decisions that improve the process. It also focuses on employee engagement, right? Employee engagement and sees continuous improvement using tools like continuous improvement tools. We have tools like Plan, Do, Check, Act or Plan, Do, Study, Act as examples uh, of continuous improvement tools. So let's add it has a employee or it also ensures that we bring employees together to achieve our total TQM or total quality management um, total quality management goals. And then again, it also focuses on continuous improvement using tools. Now, total quality management is expected to, of course, be a culture rather than just a deed. It's supposed to be something that is inculcated into the whole of the employees, the whole of the team, and how they behave, right? It's evidence driven. In other words, we use data, evidence driven, and centered around key success factors. So in other words, we set up the factors or the parameters we're going to monitor, parameters that if we succeed at, then we improve our quality chances, our chances of providing customer with the right level of satisfaction, right? And then we use evidences to monitor how we perform around these key success factors. So that's how total quality management actually works. It's of course a bigger ball game, right? It's supposed to be encompassing all around the organization, right? And uses management tools and techniques like planning, organizing, directing, and quality. I'm sorry, planning, organizing, directing, controlling to ensure that we organize and marshal our resources, shape our behavior and culture, and will improve our processes continuously towards the satisfaction of the customer. We also have root cause and failure analysis. We use this to be able to identify the root cause of failure. Now, there are very popular techniques, one of which is the 5 whys. The 5 whys will ask why 5 times until we're able to address the root cause of a situation. Now, the goal is not to be punitive. The goal is to identify the fundamental reason why a process failed, right? And then I often give this example of an aviation company that that had to make some improvements into some of his processes because the pilot came in and the pilot refused to fly on the plane. And then the company asked, okay, so why did the pilot say he wasn't going to fly for a flight that he was, pretty much scheduled for? So yes, he was not feeling very good or able to fly. So he went to request permission not to travel on the flight. And when he was asked why, he claimed or he stated that he did not get sufficient rest. And when a 5 why analysis was investigated, right, down to the reason why he wasn't able to get good rest, of course, it simply means you ask why 5 times. Bottom line came down to the fact that provisions were not made for to take care of power outages and with respect to fuel and the availability of the generator sets that could power the rooms where the pilots slept. Right. So root cause analysis is used to be able to investigate the deeper causes of a problem instead of us just running off with the obvious face value of the problem, allows us to be able to dig deep for process improvement. We also have fishbone diagram. Fishbone diagram similar, but in this case, somewhat different because if we look at the causes of the failure, so kind of root cause analysis, right? It looks at failure. First of all, we'll address the cause. So we'll begin with a problem, and we're going to have one of the things we're going to look at again will be diagrams for that will show the fishbone analysis and the fishbone analysis and the 5 why. So we have the problem. I will try to trace it into about 4 or more causes, right? So for instance, we could have cause like man, right? Is it a man problem? Is it a machine problem? Is it a material problem? Is it a method problem? Is it a measurement problem? Is it an environmental problem? So man, if it's a man problem, then it will be traced to the activities of man, maybe things like lack of training, lack of skills, negligence, right? And of course, human factors. And then if it's a machine problem, it will be traced to the inability of the machine to act, to respond or behave in the right functionality when needed. Right. Could also be a material problem, the quality of the material being fed into the machine. It could be a method problem, usage of the wrong process method. It could be a measurement problem, usage of the wrong measurement. I mean, introducing the wrong measurement as input or outputting the wrong measurements. So whatever be the case, measurement problem, or could it also be environmental factors? Now, each of these we can still drill down beyond the initial representation, like man, to drill down to understand what type of man problem. But we're going to have these in subsequent videos where we'll talk about the fishbone analysis and 5 why more extensively using diagrams. Now, let's look at the fall tree. The fall tree analysis is a bit of a top-down deductive risk analysis method that we use to identify how failure combinations, so things like failure combination, human errors, and external events can lead to a failure, like a system failure, accident, or loss of function. So it's a very popular method used in aviation, maintenance, and reliability, and industries like oil and gas, where we want to create minimum level of failure, probably because of the consequences of these failures, right? And then, of course, we have failure mode effect analysis. Now, what failure mode effect analysis does is that it identifies every opportunity for potential failures in the process, in the system, in our design, and in our products, right? We look at it from the perspective of the potential failures, right? Where are we exposed to failure? We also consider the failures occurrence from three perspectives. Number one, the probability of the occurrence. Number two, the severity of the occurrence and how easy it is to detect these failures. And we use that this data as input into calculating a risk priority number that is used to rank and prioritize these risk events for us to be able to effectively manage them. And when we we use them to be able to minimize failure that cause downtime and safety issues. Now, moving forward, we have also tools like the Pareto principle. Now, the Pareto principle is pretty straightforward. It feeds off the 80-20 principle that says that 80% of inputs can be traced or will be generated from 80% of inputs will generate only 20% of outputs, while 20% of inputs will generate 80% of outputs, right? So 80% of failure will come from only 20% of assets when the Pareto principle is applied to maintenance and reliability. Only 20% of assets will generate 80% of failures. Helps us to be able to focus on critical issues for maintenance and reliability. Now, that's even coming from 20% of assets. It could be 80% of issues will come from 20% of causes. Right. And then we use this to be able to narrow down on the most critical causes of asset failure. And when we are able to address that, we improve our our performance in maintenance and reliability. And then we have, of course, total productive maintenance. Now, total productive maintenance is yet another very interesting topic around maintenance and reliability, right? Total productive maintenance encourages cooperation between maintenance and operation, right? Now, the general idea of operations is that someone is employed to run the machine. And the general idea of maintenance is someone is employed to look after the machines after the operators are done with running the machine. So it's a difference in role that can affect the lifespan of any machine. Now, operators are often motivated or rewarded based on their ability to generate output from the machine, not necessarily keep the machines healthy. So as long as they are generating output from the machine, in other words, the machine is giving us productive units, then we really don't expect operators to maintain or keep the asset in a very good working condition. And when you see, when that attitude or when that becomes a culture and an environment, then you generally tend to see operators driving the machine to highest level of productivity without caring for things like preventive maintenance, without caring for about preventive maintenance activities, um, cleaning the machine, using the right number of hours recommended to run the machines. And all of these things can cause easy breakdown of the assets. So what we generally do with total productive maintenance is that this mindset of my job is to run the machine, give it what productivity. You see some of them boasting about it, and then leaving the machine for the maintenance people is put to an end because the operator and the maintenance team are co-working. In other words, they have co-ownership of the equipment, right? So the operators are taught to be able to take care of the machines. I mean, pretty much the way if you look at how people own their cars, most people treat their cars like, very, very good friends. When you treat a very good friend, most people treat their cars that way. Why? Because of course you can see that level of ownership. I own this asset, and if you own something, you won't want to destroy it. Right. So one of the first whole idea of total productive maintenance is fostering a culture of ownership. Right. And then, of course, co-ownership with maintenance. So while I am working on this machine, we emphasize your responsibility to keep the machine in very good working condition, right, so that you can continue to use the machine, right. It also aims for zero breakdown, no accident, and reduce operation and maintenance costs through the use of more effective processes. And then again, we have other fantastic ideas like the use of KPIs, right? We want to also make sure that we're using the right KPIs to measure the output of our productive processes, right? So yes, process variables should be measured. We use them to be able to ensure that performance is kept at the highest level. KPIs are expected to be meaningful, useful, measurable, and manageable. Right? They should be things that tell us something. The same way, if you go to see the doctor and he or she collects your vital signs, then each of these, the doctor does not collect any data that is not usable for your treatment. Ideally, would not. Right? So they collect data that is only usable. Right? So data that has meaning. Data that has meaning, data that they can easily measure, data that they can easily manage towards the treatment of the patient are the kinds of data that we collect. So it's very important that we collect also for machines KPIs that are meaningful, measurable, and manageable by the relevant personnel. We also have the balance scorecard that uses a combination of perspectives and KPIs to give us a comprehensive view of process management. So let's not forget that there is a perspective called the process improvement perspective, and it links up with the customer service perspective, and it is enabled by the growth, learning, and development perspective. And we use this to be able to manage continuous improvements within the organization. Now let's look at sub-element 3, which is our processes. We have Six Sigma, which is a set of technical tools for process improvement. The goal is to identify and remove errors in very, very key processes and early enough in the process. And the goal, the target for Six Sigma is that we should have in every million production runs, right, we have 3.4 defects in 1 million production runs. And then, of course, we have lean. The focus of lean is to eliminate waste. In the previous video, specifically the video about OEE, I spoke about waste of muda in manufacturing. There are at least 7 types of waste. There's overproduction, there's overprocessing, there's waiting, there's inventory, there's overproduction, overprocessing, inventory, transportation, motion, waiting, defects. And then there's, of course, the additional one that was introduced, which is the misuse of human talent and skills, right? No, it's not only muda that which is waste, there is also overburden of our systems, which is muri, and unevenness in our workloads, which is mura, right? So we want to eliminate waste and level load, right? Use and level. So the waste elimination, which is muda, waste actually is muda, at least for the Japanese, a term that was translated into modern English. Waste is muda. Focus on reducing overburden is also one of the things that is practiced for lean, which is muri, and then unevenness in workloads. Now, so we want to focus on or emphasize level loading schedules for cost effectiveness. And then one of the tools that's used to be able to achieve all of these lean engineering, lean manufacturing, we'll call the value stream map. So value stream map, another thing we would show in the videos, would be used to document production steps. And more importantly, we want to be able to pick out areas where there are waste. So what we call non-value added tasks are tasks that are wasteful in the process. Would have to identify value added from non-value added tasks and eliminate non-value added tasks so that we can be able to maybe not eliminate but also minimize. So the word is minimize or eliminate non-value added tasks to make the production process more efficient. And then we have the 5S framework, which is a system that is used to again eliminate waste and set up order, right? Set up order in the workplace. So we have sorts, right? Sorts means you want to keep things in their position, take things that shouldn't be, to lay things in the right places and in the right way, have straighten, put them in allocated spaces, and labels. We have shine, to keep clean. We have standardized, to use standard operating procedures or very specific work instructions to operate or manage the workspace and manage inventory. And then we have sustain, to have a culture that can sustain all of these to have a culture that encourages sustaining all of these good habits. A sixth variation or some variation carry a sixth S, which would be safety. Then, of course, we have the DMAIC, which is design, measure, analyze, improve, and control. We use them to carry out data-driven improvement methods on the Six Sigma, right? When we say define, it simply means define the project, right? Define the team, define the problem. And so define the problem, define the project, define the team, define the project, what we're going to do to be able to improve the situation, the general project. Now, when we say measure, you want to measure process capabilities. You want to measure what your current process capability is against what your desired process capability should be. And then when we finish measuring them, you want to analyze for gaps, right? What are the gaps between your current process capability against your desired process capability? What are the factors triggering or driving those gaps or differences in performance level? And then when we analyze and we understand them, then we move to improve. So sometimes analysis would have to do with using root cause analysis to be able to trace the real why those performance gaps exist. Improve will have to do with closing these gaps using by eliminating the things that result in that gaps, the root causes of those gaps, or introducing strengtheners into areas that are weak, use that to improve. And then, of course, you have control. Control simply means that you set up work instructions, you set up processes, you set up KPIs, and you monitor those KPIs, and you ensure that we don't sleep or we don't go backwards into bad habits, right? We can apply this independently as a standalone improvement method. And that brings us to the end of improvements, right? Managing, and that brings us to the end of this section. When we return, we're going to handle the third element, which is change management. How do we go about managing and implementing change in a system, in a maintenance and reliability system, or more specifically, maintenance and reliability system for a manufacturing process? Thank you very much for being with us, and I'll see you in the next video.